Some time ago, I hand modeled this Tesseract projection and printed it. I'm happy with it. I think it looks nice. Ever since then, I've wanted to get all the 4D platonic solids, but I didn't want to model those by hand. The other day, I decided to finally code a 4D renderer that makes 3D models from Polycora. I decided to use Rust for this project for no particular reason. The first thing I did was write an OFF loader. OFFs are the file format used for n-dimensional polytopes. The way they work is that they list the dimension, then the element counts, vertices, and then they actually skip edges and go to faces because edges can be uniquely derived from faces. The way my code works is that it goes through each face and only adds edges it hasn't seen before until it hits the edge count it got from the start of the file. After that, I render the polychoron to a rendered model struct. If I were to do this project again, I'd probably skip this step. It just creates an awkward intermediary between the OFF data and the 3D model. All this does is rotate the shape and divide its x, y, w values by its z value to get some 3D points and vertex sizes. These will be used for making the edges different sizes, depending on distance to the camera. Now I'll try to get STLs working before making the 3D model from the projected polychoron data. Going off of the Wikipedia article, STLs start with 80 junk bytes, then the triangle count, and finally the triangle data, which are just the normal and then the triangle's 3 points. I initially struggled for a long time to get this working, as I couldn't find how to convert a VEC F32 into a byte array. I got my dad to help and he suggested converting the floats to bytes and then adding those, and that worked. I was originally writing to a buffer because I thought it was more proper or performant due to the strange and unhelpful documentation surrounding writing binary files. After all that, the STL still didn't work. I was testing a basic right-angled tetrahedron and importing it into Blender gave me nothing. Interestingly, importing the same file to my 3D printer slicer did work. I decided to model the file in Blender and export it to STL. Looking at the files in a hex editor side by side, it didn't take me long to realize my problem. I said the model has 12 triangles because my triangle array has 12 elements. I forgot to divide it by 3. The triangles array stores the positions of the vertices, not the triangles themselves. After fixing that, it worked perfectly. At this point, it was getting late in the night of day 1, so I commented and structured the rest of the code and went to sleep. My plan for the code was that I'd write a function that builds a mesh from the render data using 2 functions. One that adds a line, which is just a cylinder with 2 different radii, and a function that adds a sphere by loading in a sphere model and pasting it at every vertex. I decided to put a link to my website into the 80 junk bytes of the STLs it generates. This doesn't matter much since you still need to process the files in Blender afterward, which would strip the junk bytes, but oh well. When I started working on it the next day, I couldn't figure out how to get 2 vectors that were both perpendicular to each other and a third input vector, whilst having a consistent chirality rule. The trouble is that this is a multi-valued function, which is hard to design for. I asked my friend for help with the math and they were able to come up with a formula, which was super nice of them. Why did I need this? Well, if you have the axis between the start and end points of a line, in order to put a ring of points around that, you need 2 perpendicular vectors inside that plane. Once I had those, I was able to loop through evenly spaced angles at an arbitrary resolution, and then place 4 triangles. 1 for the top, 1 for the bottom, and 2 for the side. I ran it and it actually worked first try. Not even any backwards faces. I was very pleasantly surprised. Now the only thing left to do was to add spheres at every vertex. I tried doing the STL loading thing like I said I would do, but man, writing an STL parser is so much harder than an STL writer. I gave up and just generated an icosahedron instead. This looks pretty bad, but the plan was to use Blender's remesh function regardless, since a bunch of intersecting cylinders doesn't look very good. Lastly, I added an orthographic mode, some rotation functions, and made an option to cull vertices behind the object. This makes things a lot cleaner and more realistic. And with that, the project was finished, in just 2 days. Wow, I spent several months putting this off and I made it in a weekend. Well, at least I can turn it into a quick video. I hope this was fun to watch. Presenting a project in an interesting way is difficult when the problems are all solved. The Git repo will be in the description. Thanks for watching.